Let's go through LeetCode 987, vertical order traversal of a binary tree. And this question is pretty much similar to the question number 314, except that under the same level. For example, this one, it has a column 0, row 0. So it will for the column 0, it will show first. And for 6 and 5, you'll see the column is 0 and the row is 2. They both have the same row and column index. In that case, we need to have a sort 5, 6. So for this one, because there is a sort for each layer, right? So sublist or each result that may have some kind of sort. So we cannot get O(n) time complexity anymore. But the thing is that we still can use the minimal column index and the maximal column index, but we just sort those kind of collections inside, right? So we say in this case, the sort, the worst scenario for the sort is that it will be in H. For each one it is log H, right? So time complexity will be the n log H, the worst case, because I assume we will sort everyone. The worst case is that this collection, for example, is a head. As we cannot get O log n, so we can do this using as we cannot get O(n) time complexity, so we can write this solution in multiple ways. For example, we can do like 314, right? We still use a minimal and a maximal because otherwise, if we sort everything, it will be n log n time complexity. But if we use a minimal index and a maximal index, we can get n log h. It's still a bit better. So let's use in different way to do this kind of scenario, this kind of questions. First is BFS, right? So it will be pretty much similar to what we do in question 134. Let's say for if root equals null, we just return result. And we are going to have a Q tree node. Q equals new array back. And we are going to have a row equals 0, column equals 0, right? So we are going to have another Q. And we are going to have this main column equals 0, max column equals 0, right? Q, we use this one to store the row and column coordinator. We call row column Q, okay? New array back. So we need to Q offer root, right? in the row column queue offer new int row column, right? Let's say while queue does not be is not empty. We have three node equals queue dot pull, and we'll also get a current coordinator that is row column equals row column queue dot pull, right? So we'll have row equals we'll have this. What about yeah, we already have this. So we pull this. So we need to have map, right? Map to store those kind of map to store the results. But the thing is that for this kind of map, we need to have the column as a key, map integer. But for value, we'll have row and the root value. Use a integer array to it. So we'll have map compute if absent row column one, right? This is column. It goes to new array list. Add new int row RC0 is its row, right? And we are going to have the root dot value, right? Node dot value. So I say if node dot left that's not equal to null, right? And if node dot right doesn't equal to null, we are do two things, right? The node left doesn't equal to null. That is we're going to first we need to have a queue offer node dot left, right? And we need to update the we can have a min, right? Min column equals mass dot min column, and this one the one, right? Column is one minus one. And we also have a RCQ offer new int. The row we go to is the child, right? Left child. So it will be row plus RC0 plus 1. And the column will be RC1 minus 1. Right. So on the right, we will offer node dot right. Min max column equals max dot max column. RC1 plus 1, right? Plus 1. And we have RCQ of new int. It's right child will have the row plus 1. And then we'll have the column plus 1. So we get this one. The key will be the column. This list of integer array, right? This integer array, the first element is the row, the second element is the node value. So we need to iterate this map to get our result. So we have a list integer result equals a new array list, right? So here we can save the key iteration, right? Because we know the minimal column, the maximal column. So we have say for int key equals the minimal column. The summary equal to max column. The plus plus. And we are going to have a list int list equals map get key, right? So here we need to sort collections. Sort this list. Well, let's write a parameter comparator A. Let's see, first of all, it need to compare by the row, right? So let's say A0 equals to B0 or not. If it is bigger, then we compare the node value. It is equal, right? That means they are in the same layer. We compare the node value, so that there will be integer compare A1 B1. Otherwise, we need to compare the layer, the row, right? A0 B0. After this sorting, we need to create a list to every this can list the integer integer array. We need to create a list integer equal answer middle array list. Then we are going to have a for int array in this list. We're going to have a source add list get no answer add we have array 1, right? Array 1. Then we'll have a result add answer and return result. Already have a result. We already defined this on here, so we don't need to define anymore. Yeah, so this is BFS, this will be the whole n log h time complexity. And we can also use a DFS to do this. The thing here is that I think we still need to get this kind of map, because and do the logic here, right? The only thing we need to do to change the things is the structure of a BFS. So for the DFS way, we change. We don't need a queue. So let's comment this part. So this will be the BFS solution. This is messy one. For DFS, that is we need to compose this kind of map. And also we needed a minimal maximal, right? But for the DFS, if we put this one as a global variable, so it will be a bit ugly, right? So we are going to have this one, min max plus mu int 2. Right. We're going to pass this one into DFS, DFS, yeah. So for DFS, we are going to use the pre-order traversal. Actually, we can do in order or post order. All our work, we are going to do the recursion way right now. Let's say the DFS root. We have the 0 as a row, 0 as a column. And also we have the min max. We are going to update this. And also we have the map, right? We want to get this. And we have the have this int min column equals min max 0, and max column equals min max 1. Okay. So we need to write a DFS function for this. Private void DFS. We will have a tree node int row int column, right? And we need to when we DFS, we can calculate the min max. And this one this one we need to get this result, right? So we need to have this one as a parameter. So we're right, if node equals to none, we just return, right? Otherwise, let's say it will always not be. If this one equals none, then we return. We'll have first we need to try to see whether we need to update this min max, right? Min max 0 equals max dot min min max 0 in the column. Min max 1. This is max value, right? Because max dot max min max 1 column. And for this row column, we need to add to this map, right? So we'll have map compute if absent column. K goes to new array list. We're going to add new int. We are going to add a row, right? And also node document. This is a pre-order traversal. Then we need to do the left child and the right child. So for the left child is DFS node dot left. So it'll be row plus one, right? Column minus one, meaning max and the map. For the right child is DFS node dot right. Row plus one, column plus one, mean max map. Right. So this is will be the DFS solution for this. And after we get this kind of map, right? We still do the same logic here to get a result. So this will be the second solution, like a DFS, right? We know DFS for tree is just a traversal, right? So we can also use those kind of trees traversals template to do this kind of question. I mean, we can use non recursive way, but iteration way, right? So this will be the comment list. We can use a iteration way to write this as well. This will be message 2, right? All right. Comment message to DFS. That is recursion. Message to DFS recursion. We know actually for tree DFS is just a pre-order, in order, or post-order traversal. So so we can use those kind of recursion way to do this as well. So let's first write the pre-order. Okay, so let's recover the pre-order template or pseudocode. Well, how can we write a pre-order? Pre-order, right? That is the iteration way. Pre-order traversal. Pre-order, that is, we know if we are going to have the stack, right? Array stack. Tree node stack equals new array stack, right? And we are going to use stack dot push, right? Push some kind of tree node root, right? And we'll say while this stack is not empty, we have root equals stack dot pop, right? Pop. And for pre-order, there is something logic in here. For example, if you want to print something, right? And we'll say if node dot write, because that's stack, the order is reversed. So let's say if write doesn't equal none. We'll have stack push node right, and if node dot left doesn't equal to none, we'll just have a stack push node dot left, right? So this will be the template to write using the iteration way to write a pre-order. So for our code, right? So this is a template, pre-order template. Let me comment this. Okay. Order iteration template. So for our code, what we need to change is that we can still use this, but we can have another stack called a coordinator, right? To store the coordinators, like what we do in the BFS array, like row and column or RC stack, okay? Goes view array stack. And we push root, but now we also need to have a row equals to 0, column equals to 0, mean row, mean column equals to 0, max column equals to 0, right? And we need to have a coordinator stack push new int row column, right? We get this one coordinator out. Okay, we also need to have the coordinator out. That is, let's call C RC equals stack, RC stack. Oh, right. So we'll have the have this, and when we get this one, we have a logic here. That is, we need to have a map, right? Map compute if absent. RC, we need to have the column, right? Column 20. It's a key column as a key. Okay, goes to new array list. And we need to add new int. So this will be the row, right? Row will be RC 0. And the column will be root value, right? I mean the second value will be the root value. And here we also need to push the new coordinator to the coordinator stack. But before we push, we need to do a compare, because we move to the left or move to right, the column index changed. So we'll have because move right, we just need to compare the maximum. So max column equals max dot max column. RC column is 1, right? Plus 1. And we need to have RC stack push new int. Well, get its right child, we have a row that is RC0 plus 1, and the column also need to plus 1, right? And then for its left, we will have min column. We need to compare if this one is the mean smaller than min column. So we need to have min column RC1 and -1, right? RC stack push new int. For this left child, it's RC0 row +1, right? And column 1 -1. So for this code, this logic, we don't need to change. If node dot write and equal to now, here we 91 90, all of that is 91, right? Push new, cannot find the symbol. It's RC stack. And 91, if know the dot here, let's call it a node, okay? Because no. She node. So this will be the iteration way, do the pre-order, right? So this will be also be the message 3. Let's recover the template to write in order traversal, right? In order traversal. So we know for in order traversal, we also need to be able to write it quick. That is the iteration way. Let's say this is method 3, method 4, like method 4, right? Method 4. In order traversal. Actually, you see, for this recursion way, it in order or pre-order, post-order, it doesn't matter, right? Just as long as we can get every nodes. But we can use this way trying to recover how to write pre-order, in order, or post-order. So iteration way, right? We need to write the template for the in order traversal. That is, we have a stack node, right? Stack equals new array stack. The logic is while this kind of stack is not null, it's not empty, or root don't put null, right? And we have another while this root don't put null. We'll have this kind of stack push root, and we'll have a root equals root left, and here we have a root equals stack dot pop, and we'll have a root equals root dot right. We will put the logic inside here. So this will be the in order traversal's template. To do this question, we can also, this is template. We can also use this kind of template, right? So this will be the in order template. So to do this, use this template, what we need to change is also not hard, right? So we need to have this. And we need to have what this one. We push this route, and when we push this route, we also need to have a RC stack, right? We should have an RC stack to store the coordinator. We are going to use this for RC stack because new array stack. We need to add another coordinator that is RC stack push what? Actually, let's have a int row is 0, column equals 0, and min column plus 0, max column equals 0, right? We need to push new int row column, right? And when this one moves to the left, when this one moves to the left, we know the it goes to the left child, so it's we have the row plus plus and column minus minus, right? We don't need to update the column, trying to compare whether this is smaller than the minimum column, because we didn't check the left whether it is not or not. But when we pop this one out, right, we will never. Instead we pop out this kind of logic here, right? So when we pop out, we also need to pop out the coordinator here, right? So RC because RC stack will pop. Here, we need to try to see this row or column has been out-of-bound or not. And we'll get this one. We can also update this value. Row equals RC0 and column plus RC1, right? And we'll have the min column equals next dot min min column column. Yeah. And max column equals next dot max column. And we also need to have the map compute if absent, right? So we'll have the column K goes to new array list. Add new int row, and this kind of root dot value. And when we go to write, we also need to have row plus plus column plus plus, right? Because we go to its child right child. So this is a in order traversal. And this is method 4. For method 5 is post order traversal. I'm going to just write the template here. I'm not going to write because it is the same. It doesn't matter. But we can write this quickly. Let's go through this quickly. Doesn't matter. For the post order traversal, the template, let's still remember how can we write the post order traversal. We know it also needed a queue, right? Let's trying to recover. How can we write a post order traversal? We still need a queue. So let's method 5. All right. Method 5. Let's comment this. We still need this because we still need the functions. Method 5 post iteration way, right? Iteration way post order. So let's write a template for post order that is still we need the queue stack, right? Stack queue node stack with new array stack. And what it do is that the stack push root, right? And here we just say while this stack is not empty, right? It's not empty. We need to push tree node. Okay, node equals stack dot pop. Then we're going to do something, right? For example, we have a list. Add this node dot value, right? Then we need to have a stack. Have if node dot left, and equal to now. We have a stack push this node dot left. And have if node dot right and equal to now. We have a stack push node right. This is post order traversal, and after this one, because this is stack, everything is reversed in the list, in this kind of list. So if we need to have the order like the post order, we should have the collections reverse list. So this is the post order traversal template. But for us, we don't get we need to get this list, right? So what we need is just the min row, max row, or all those kind of just use the traversal to get this map, right? This map. So we do the same way like the other things. We just use the R like we call RC stack plus new array stack. Right? We will have int row equals 0, column equals 0, and the min column equals 0, max column equals 0, right? And RC stack push new int row column. And we pop this one here. And we also need to have the coordinator here, right? We need that is RC equals RC stack dot pop. And we'll have a map compute if absent. RC will have the column, right? We didn't have the column change here, so we don't need to worry. Only when we push those kind of value into the left to a stack, compare with it will update the min column or max column. So K goes to new array list, add new int RC1 node dot value. And here we need to compare. For example, we have RC stack, which for its left, that is new int RC0 plus 1, right? RC column -1. And we are also update min column equals max dot min column RC1 -1, right? And here we need to have RC stack, RC row column stack, which new int. This is right. So it will be RC0 right child RC1 plus 1. And then we also need to update max column equals max column RC1 plus 1. So because we didn't actually do traversal, we just need to get the map. So there's nothing like a collections reverse here. So there's something wrong here. 3, 2, 2. 3, 2, 2. I think there is some kind of this one, right? We should have the row as a first one. Okay, so all of these methods, the time complexity will be O in log H because we thought is just here, right? And so space will be ON. We use a stack or deck, those kind of data structure here.